Assalamu alaikum wa rahmatullahi wa barakatuh. This is Mr. Salah Ibrahim, and this is the second part of the first lesson. It's called Motion in One Direction for third prep. So if this is your first time for watching me, you have to watch the first part first. Now let's start. We have three types of speed. The first one is regular speed or uniform speed. The second one is irregular speed. It's called also non-uniform speed, and the last one is relative speed. In the first video we learned more about the regular speed, and in this video we're gonna learn more about the irregular speed and the relative speed. So let's make a revision. So we can say the object move with a regular speed when the object cover equal distance in an equal period of time. And now we're gonna learn more about the irregular speed and the relative speed. First, we will know about the second type. It's called irregular speed or non-uniform speed. We have the first definition of irregular speed. It's mean we can say the object move with irregular speed or non-uniform speed when the object covers equal distance in unequal periods of time. That mean in this example here we have this car. It's also, and we have 4 points O, A, B and C. So we can say the car move with irregular speed when this car cover equal distance in unequal periods of time. Like what? Like here, from O to A, the car covered 2 meters, that's right. So the distance here is 2 meters in 1 second, and the time is 1 second. From A to B, the car also covered 2 meters, from 2 to 4 meters, so it's 2 meters in what? In 4 seconds, but the time here is 4 seconds. And also the car from B to C covered 2 meters, but in 5 seconds. So the car covers equal distance 2 meters, 2 meters, 2 meters in unequal periods of time. Look at here. The first one in 1 second, and second one is 4 seconds, and the last one in 5 seconds. So now we can say the car moves with irregular speed. Why? Let's calculate the speed between each 2 points and know why. First, we have 2 meters distance and 1 second. So speed is distance over time, as we said before. So 2 over 1 is 2 meters per second. So from O to A, the car moved with 2 meters per second. But from A to B, the distance here is also 2 meters, and the time is 4 seconds. So distance over time is 2 over 4. It's equal 0.5 meter per second. And from B to C, the car moves with 0.4 meter per second. So the speed equal distance over time, it will be 2 over 5 equal 0.4 meter per second. So the speed here in this example, it is not constant because it's variable. So it's irregular speed. The car moved with non-uniform speed or irregular speed. But if the speed constant, we can say the car moves with a regular speed or uniform speed. But the speed, it is not constant in this case, so we can say the car moved with irregular speed or non-uniform speed. There is a second definition of irregular speed. We can say the object moves with irregular speed when it covers unequal distance in equal periods of time. Okay, so the first one, it's equal distance in unequal periods of time, but in this time it's unequal distance in equal periods of time. So look at here, from O to A is 1 meter, and from A to B is 3 meters, and from B to C is 2 meters. So the object covers unequal distance in equal periods of time. So let's calculate the speed between each 2 points to know why the car moves with irregular speed or non-uniform speed. First, from O to A, the speed is 1 meter per second because the distance here is 1 meter from 0 to 1. So it's 1 meter over 1 second. so it will be 1 meter per second. Second, from A to B it will be 3 meters per second, because the distance here is 3 meters. From 1 meter to 4 meter at 3 meters, and the time here is 1 second, so it will be 3/1 equal 3 meters per second. Finally, between B and C it will be 2 meters per second, because the distance here is 2 meters, because it's from 4 meters to 6 meters. Over the time here it's 1 second, so it's equal 2 meters per second. So look at here, also the speed, it's not equal, so it's non-uniform speed, it's unequal speed. So as you see here, it's difficult to calculate the total speed of the car. So when we move to irregular speed, it's hard to calculate the total speed of the car. So we use the concept is average speed. So to know the average speed, we have to calculate the total distance over the total time, and its law is V dash equal total distance over total time. So let's calculate the average speed in the first example. So the total distance here is 6 meters, and the total time is 1 plus 4 plus 5, it will be 10 meters. So the average speed, it will be 0.6 meter per second. So the car move with the average speed equal 0.6 meter per second. So let's calculate the average speed in the second example. The total distance here is 6 meters also, and the time is 1 plus 1 plus 1, it will be 3, so 6/3, it will be 2 meters per second. So let's solve a problem. A racer running and cover a distance 100 meters of a straight track in 10 seconds. Then he returning back walking, he took 80 seconds to come back to starting point of running. He need to calculate the average speed while running and while returning and during the whole trip. So let's calculate it. The very important thing here to drawing the path of the problem. It will make the problem very easy for you. So look at here, this is a racer and he cover a distance 10 meters of a straight track like this in 10 seconds, and he returns back in 80 seconds to the starting point. So we have two paths here and two distance here. He want to calculate the average speed while running. So while running, the distance is 100 meters and the time is 10 seconds. So the speed is 100 over 10, it will be 10 meters per second. But while returning, the distance here also 100 meters and the time is 80 seconds. So the speed, it will be 100 over 80, it's equal 1.25 meters per second. Finally, during the whole trip, we have to calculate the total distance while running and returning. It will be 200 meters because while running it was 100 and while returning it was 100 also. So 100 plus 100, it will be 200 meters, and the total time is 80 plus 10 seconds, it will be 90 seconds. So the average speed during the whole trip from the starting point to the ending point, it will be total distance 200 meters over total time 90 seconds equal 2.22 meters per second. Now there is a note here. When the speed equal the average speed, this motion described as regular speed, because in this example the car moved with a regular speed. We knew it before. So let's calculate the speed between each 2 points to know. So the speed from O to A is 4 meters over 2 seconds, it will be 2 meters per second, and from A to B it will be also 2 meters per second because 4 meters distance and 2 seconds time. And finally between B and C, also 2 meters, because the distance here is 4 meters over 2 seconds, it will be 2 meters per second. And also if we calculate the average speed, in this case it will reduce also 2 meters per second, because the total distance here is 12 meters over the total time is 2 plus 2 plus 2 is 6 seconds. So 12 over 6 equal 2 meters per second. So when the speed equal the average speed, the motion described as a regular speed. But when the speed unequal the average speed, we describe this motion as irregular motion or irregular speed. So let's calculate this example. The speed between O and A is 1 over 1, it will be 1 meters per second, and the distance between A and B 3 meters, and the time 1 second, so the speed is 3 meters over 1, it will be 3 meters per second, and the distance between B and C 2 meters, and the time 1 second, so the speed is 2 meters per second. So as you see here, the speed is unequal, and if we calculate the average speed here, it will be 2 meters per second, because the total distance here 6 meters and the total time is 3 seconds, it will equal 2 meters per second. So when the speed unequal the average speed, it's described as irregular speed or motion. So this is the average speed and the irregular speed. So let's learn more about the relative speed. There is an example here. If there is a person in a car that moved at 80 kilometers in a certain direction, then a car moves at 110 kilometers per second past him in the same direction, and there is a person standing on the side of the road and he observes the speed of the moving cars. This person is called the observer. So if we want to calculate the speed of the slow car, this car, relative to this man that is standing on the ground, it will be 80 kilometers per hour. That's easy. Okay, that's the real speed that car move with it. And if we want to calculate the fast car according to or relative to this man also, it will be 110 kilometers per hour, because it's the real speed that car move with it. But if we want to calculate the speed car relative to this man in this slow car, it will be 30 kilometers per hour. So he will measure the speed of the fast car with 30 kilometers per hour. But if we want to calculate the speed of the slow car relative to the man in the speed car, it will be minus 30 kilometers per hour, because the observer's speed here is 110 kilometers per hour and the slow car is 80 kilometers per hour. So this man, see, this car moves with minus 30 kilometers per hour. And now don't worry, and I will tell you the laws of the relative speed right now. We have 4 cases in the relative speed. The first one, when the observer is at rest, the relative speed equal the real speed of the object. That makes sense. But when the observer in the opposite direction of the object, the relative speed equal the real speed plus the observer speed. And this is explained when we see the cars in the opposite directions move with a very high speed, because the relative speed equal the car speed plus our speed. So the real speed here we can calculate it with the relative speed minus observer speed. It's easy. Case when the observer moving in the same direction of the object, as we talked before in the last example, the relative speed equal the real speed minus observer's speed, as we know it. In the previous example, it was, in the first case, 110 minus 80 equal 30 kilometers per second, and in the second case 80 minus 110 equals negative 30 kilometers per hour. The last case, when the observer moving in the same direction at the same speed, so the relative speed it will be 0 because the two speeds equal and the difference between the two speeds equal 0. So we will see the car is at rest. So when two cars move in the same direction with the same speed, the two cars see each other at rest because the difference between the two speeds equal 0. So we finished the last part of this lesson. So we finished this lesson and see you on the next lesson in the next video. And if you have any questions, leave it in the comments below and I will answer you. So goodbye.